What did I say it was? The mass. Okay. So if we take a look at hydrogen, there are two common isotopes of hydrogen. Notice what happened to the atomic number in our notation. Stayed the same. Why did it stay the same? Because I'm looking at hydrogen. If I change the atomic number, it's not hydrogen anymore. So we're making sure that we look at the same element. You'll notice that the mass number in the upper left-hand corner has changed. What is the difference between these two?
1.
I knew you were going to say that. Let's go a step beyond 1. 1 what? Don't tell me AMU. Neutron. We've added a neutron to go from hydrogen with an atomic mass of 1 to hydrogen with an atomic mass of 2. All we've done is added a neutron. Okay. Do we need any neutrons for hydrogen? No. Why not? What was the point of neutrons? To keep protons stuck to each other. But how many protons does hydrogen have? 1. There's no need for a neutron. Which means we don't expect to find a lot of hydrogen with neutrons in their nucleus. Is this revealed in the periodic table? The atomic mass for hydrogen is 1.01. A very small percentage of hydrogen has a deuterium or has a neutron attached to the nucleus. It's enough that the atomic mass changes and we have to account for that change. Okay? So when we're looking at hydrogen, it is composed of all these different isotopes. Depending on how popular those isotopes are, they may get different names. Hydrogen being the simplest, each of its isotopes gets named. We have, I don't know why that name all of a sudden struck me as weird, Protium. Then we have Deuterium. There's actually another one called Tritium. Okay, what's tritium?
3.
Hydrogen with
2.
2 extra neutrons, which gives it a mass of 3. That's it. Okay? So how do we determine the value on the periodic table? This is coming from an average. So let's average the atomic mass of protium and deuterium. How would we do that? So we would take 1 being the mass of protium plus 2 being the mass of deuterium, and we divide by? Why do we divide by 2? There's 2 of them in our average. And we would get a mass for hydrogen being 3 over 2, also known as 1.5 AMUs. Is that the mass of hydrogen reported on our periodic table? No. Why not? This calculation that we just did implies that we have an equal concentration of protium and deuterium. So let's break this calculation down into its individual component parts, which I know is going to look a bit gross, but we're going to do it anyway. We have 1 times 1 over 2 plus 2 times 1 over 2. Everybody see that? Okay. What we can do is split this fraction. You'll notice that I included 1 out front and 2 out front. Okay. And in that first case, it's a bit redundant to include the 1. 1 times a half is going to be a half. Why did I include the 1 there? Where did it come from? Yes. That is the mass of protium. What did the 2 mean? The mass of the deuterium. In our simple calculation, what we have assumed are these 1/2. What are those 1/2? The fraction or our percent of the whole sample. Okay? When we did our simple average, what we assumed is that it was 50% protium and 50% deuterium. In calculating an average, that is necessarily what you have done. That clearly did not come out to be true. What are those percents more likely? Well, we just talked about hydrogen. It shouldn't need an extra neutron. Okay, so how many times do you think we'll put a neutron into a hydrogen, say out of 100 times? One time. One time out of 100 times, which means we have, percentage-wise, we'd have 1%, which in a fraction would come out to be 0.01. So I would take the mass of my protium times its percent, pen, thank you, sorry, kind of shouted into the microphone there. And we said our deuterium 1 time out of 100, so we could write it as our percent there, 1 out of 100. And then this would then equal our periodic table, so we'll just say PT. But to solve for that, I would then need to know what this percentage was for the protium. Well, we didn't figure that out. What is that one? How did you know it's 99? That's what's left over. We're running under the assumption that there's only 2 common isotopes. One of those isotopes shows up 1 in 100 times. What are the other 99 times? Our protium. So we have 1 times 99 over 100 plus 2 times 1 over 100. And anybody with a calculator should come out with a number that is darn close to 1.01. Okay. How would you go through and predict these for other elements? You wouldn't. You'd be told. That's about it. Okay. So to figure it out, the mass of one isotope times the percent of that isotope plus the mass of the next isotope times its percent will equal the average atomic mass. That should match what's on the periodic table. Go ahead.
You said we'll be given the percentages?
You will be given any one of those possibilities. Okay. Or, sorry, you'd be given any 4 of those possible things. Why 4? There's 5 possible things to solve for. You'd have to be given information to get you 4 of them.
So, I just don't understand the whole percentage thing.
What do you mean? Where did I get what percentage?
Like the 99 over 100 and 100 over 100.
What we did is guessed.
Okay.
That's all we did for those. It said, why 1 out of 100? Well, we went back and thought about hydrogen. Right? This is the only case that we can do it for because hydrogen is the smallest, simplest element. That's the only reason we can do it. As soon as we scale up to any other element, it gets vastly more complicated. We can't just guess at values. Okay. So you would be given a percentage. Say like, let's see, I'm pretty sure there's an example. There we go. Let's take a look at that question. I know there's a bunch of text up there. Don't worry about all that text. We just talked about all that text. Here's your question. Gallium has 2 isotopes. Gallium-69 with a mass of 68.926 AMUs and a 60.11% abundance. And then we also have gallium-71. What is the mass of gallium-71 in AMUs to 4 significant digits? All right. So set it up. See what you can come up with if you got a question. Good thing that might be helpful to reference would be the equation we just talked about. So we can do that. The mass of A times the percent of A. And somebody's already got it memorized. Good call. Mass of B times the percent of B equals our average, and in particular our weighted average. Weighted by the percents that we've put in there. So what you should be able to do is now find in the text values that you could sub into this equation to then solve.
So when it says 60.11,
Okay. So let's go through and identify 4 things that I've given you to be able to solve. Number 1, 68.926 AMUs. That has been given. That is the mass of what? Okay. At this point, we can label it as anything we want. Mass of A seems to make the most sense. Okay. Next thing I'm giving you, 60.11%. What is that? That is the percent of, isn't it A? Yeah, that's A. The mass and the percent matched with each other. Okay. And then I don't see any more numbers. So we said in the equation, to solve this, we got 5 things. I have to give you 4 of them. And yet I've only given you 2. And somehow I still expect you to be able to solve. Yes?
So we can figure out the other percentage, how does that add up to 100%?
We know the percent of A plus the percent of B, that's a plus, must equal 100%. Which means percent B will be 39.89. I'm trusting you guys to that. Percent. There's our 3rd term. I did give you that, but I made you do a calculation to get it. Fair enough. So we said 5 things. You needed 4 of those. You now have 3 of them. You're still missing 1. Right. Some people have picked up what it is or what that missing 1 is, but maybe you haven't yet. So let's go through and actually start to plug and chug with this. The mass of A we said was what? 926. The percent of A was 60.11. If you write it in as 60.11, you have to say percent. Per meaning division, cent meaning 100. It's fine. Plus the mass of B. What is the mass of B? We don't know. That's actually what we're trying to solve for. So that's good. So we didn't know that, because if we knew that, it was an awful lot of work. Could have just written down the answer. Do we know the percent of B? Yeah, we just calculated that to be 39.89 over 100. And then this must equal our weighted average. What kind of a jerk wrote this question? Didn't give me the weighted average.
Wouldn't it be, can you figure it out?
The periodic table gives you the weighted average. On every single test, you have the periodic table given to you so that you don't have to look at the big ones on the wall. Right? You have the periodic table. Use it. What is the weighted average for gallium?
69.72.
Now what can you go through and do? Solve for your variable. In this case, we set it up as B. Okay? We would then have our final answer, which I don't know what the number is, so we're going to trust Adrian here. Put you under the gun. 70.92. Other people get that? Can we get a confirmation? We got a yes. So we ended up with 70.92 AMUs.
If we don't put AMUs on the test, will it be wrong?
On a show your work, if you did not put AMUs, you would lose points. Because it's show your work. You need to specify your units. On a multiple choice, the odds that I'm going to waste an answer choice of 70.92 with nothing and then provide another answer choice of 70.92 AMUs, probably not going to happen. Okay, so you probably don't have to worry about your unit on a multiple choice. Last thing that we want to throw in here is an approximative skill. Okay. We're starting with a mass at 68.926. It somehow averages out to 69.72. Okay. What does that mean the mass of B needs to be? It has to be bigger than 68.926. Why? Otherwise, I don't get an average that comes out appropriate. Okay? That already can eliminate answer choices. Take advantage of that. How much bigger should it be? 20 units? Look at this change, 69.72 versus 68.926. How much bigger is it? About 1. If this was a 50-50 mixture, it would then be even up the other direction to get to your other number. Okay? It's not exactly 50-50. So by looking at the numbers and understanding what those calculations are, you can roughly approximate and at very least eliminate answers without having to do the calculation. That requires a much greater understanding of what you're doing, which ultimately comes from practice. If you don't do the practice, all you're doing is crunching the numbers and hoping for the best. Which is fine, that works. Okay, questions on that? Okay, because I think, yeah, we're pretty close to this. This is a little outside concept. Heavy water, D2O, you may have heard of heavy water. We've just exchanged the hydrogens for deuteriums. So there's an extra neutron on each of those hydrogen atoms, and we end up with heavy water. Heavy water because it has 2 atomic mass units more than regular water. There are people that will go through and isolate D2O out of standard water streams. Okay? So you can just take standard tap water and you can get D2O out of it. Okay? It's just in there in a very low percentage. We just ran a calculation. Deuterium made up 1% of all hydrogen. So 1 out of 100 molecules of water is half heavy water. Okay? So you could isolate heavy water. Why would that be important? There are some experiments where we don't want hydrogen, we want deuterium. Because deuterium is not visible, but hydrogen is. So there are people that will go out and say, I need to buy heavy water so that I don't see that hydrogen show up in my experiment. Okay? You now made money because you're selling heavy water to somebody, and all you did was purified your water stream. Okay? It's a little bit more complex than that, but that's the gist of it. Okay? It's something you could do at home, theoretically. This last little part is just kind of an important slide to address. We've talked about things to memorize. This comes from the nomenclature video. There are polyatomic ions that you are required to memorize. Everybody grunts and groans, oh my God, you're making me memorize more stuff. You already memorized the periodic table. I'm just giving you 6 more things to memorize. Okay? It's not breaking the bank. The ones that are starred are the ones you need to memorize. What information do you need to know from that to memorize? The formula, the charge, the name. All 3 pieces must be memorized because you have to be able to use all 3 of those when you go through and deal with nomenclature. There are a lot more than these possible complex ions. I told you to memorize 6 because these 6 show up the most frequently. Okay? These you will guarantee 7?
Yeah, 7.
7. So I can't count. Well, arguably some of them aren't all that important. Okay, these just happen to be the most important 7 that I've seen show up again and again. So memorize them. Starting on Tuesday, we'll have a quiz. The quiz will be this. You've seen it? It's there. That's the quiz. I would highly recommend you do the quiz ahead of time. This one will get graded very nasty.